Hello everyone, I'm Dr. Fahim. Today we are going to discuss the lecture 2 of cryptography and network security. In lecture 1, we are discussing the security goals, security services, security mechanisms, and active and passive attacks. As we know, security is the major aspect to store information and send it across the network with secure manner. In order to secure our data or information, we are using the two prevalent techniques, which are cryptography and steganography. Firstly, we briefly discuss the cryptography. After that, we will see what is steganography. Cryptography, a word with Greek origin, means secret writing. However, we use the term to refer to the science and art of transforming messages to make them secure and immune to attacks. Although in the past, cryptography referred only to the encryption and decryption of message using the secret key. But today it is defined as involving the three distinct mechanisms, which are: first is symmetric key encipherment, second asymmetric key encipherment, thirdly is the hashing. Later we will discuss in more detail about all the three mechanisms. So here is the second steganography, with origin in Greek, mean covered writing, in contrast with cryptography, which mean secret writing. Cryptography means concealing the content of a message by enciphering. Enciphering, in other words, we say we convert the message into ciphertext by using the encryption algorithm. After that, this ciphertext can be decrypted by using the decryption algorithm and the similar key and convert into the original message. While steganography means concealing the message itself by covering it with something else. This is the major difference between the steganography and the cryptography. The modern use of steganography is any form of data such as text, image, audio, video can be digitalized, and it is possible to insert secret binary information into the data during digitalization process. Such hidden information is not necessarily used for secrecy. It can also be used to protect copyright, prevent tampering, and add extra information. The cover of secret data can be text. There are several ways to insert the binary data into an initious text. For example, we can use single space between words to represent the binary digit 0 and double space to represent binary digit 1. The following short message hides the 8-bit binary representation of A in ASCII code. Next is the model for network security. Uh, this figure explains a message is to be transferred from one party to another across some sort of internet services. The two parties who are the principal in this transaction, sender and the recipient, must cooperate for the exchange to take place. A logical channel is established by defining a route through the internet from source to destination and by cooperative use of communication protocols such as we say that TCP/IP protocol by the two principals. For example, a third party may be responsible for distributing the secret information between the two principals who keep it from any opponent, or a third party may be needed to arbitrate disputes between the two principals concerning the authenticity of a message transmission. The general model shows that there are four basic tasks in designing a particular security services. First is design a suitable algorithm for performing the security related transformation. The algorithm should be such that an opponent cannot defeat its purpose. Second is that generate the secret information or secret key to be used with the algorithm. Third is to develop a method for the distribution and sharing of secret information. Fourth is specify a protocol to be used by two principals that make use of security algorithm and the security information to achieve a particular security services. This figure also shows that in which who is the opponent, which may be the human, such as like we say the hackers. Also opponent may be the software, antivirus or worm. Also we will see the what is the information system, maybe the computing resources, processor, memory, input output devices, or maybe the data, maybe the process, software, and internal security controls. Next is the cryptography. Any cryptographic algorithm are characterized along three independent dimensions. Firstly, is the type of operation used for transforming plain text to ciphertext. All encryption algorithms are based on two general principles. First is substitution, in which each element in the plain text, such as bit, letter, group of bits or letters, is mapped into another element, and transposition. Second is transposition, in which the element in the plain text are rearranged. Fundamental requirement is that no information be lost, such as that all operations are reversible. Most systems refer as product system, which involves multiple stages of substitution and transposition. Next is the number of keys used. If both sender and receiver use the same key, the system is referred as symmetric, or we say that single key, secret key, or conventional encryption. If the sender and receiver uses different keys, public key and private key, the system is referred to as asymmetric. In other words, we say two key or public key encryption. Third is the way in which the plain text is processed. A block cipher processes the input one block of element at a time, producing an output block for each input block. A stream cipher processes the input element continuously, producing output one element at a time. And in the block cipher, we further divide it into binary block cipher and non-binary block cipher. Later we will discuss in detail. Here is we are briefly explain the cryptographic system. Symmetric key encryption is sometimes called secret key encryption and secret key encipherment or secret key cryptography. An entity say Alice, another entity say the Bob. This is the most common example of Alice and Bob, which are used during the explanation of cryptographic algorithms. So we will also discuss the same example. Alice can send a message to another entity, say Bob, over an insecure channel with the assumption that an adversary, say Avi, cannot understand the content of message by simply eavesdropping over the channel. Alice encrypt the message using encryption algorithm, whereas the Bob decrypt the message using decryption algorithm. That's why the Avi didn't understand, even though he or she dropping the message in over the channel. Symmetric encipherment uses a single secret key for both encryption and decryption of message. Previously, we also discussed the same key is used for the encryption and the decryption of message. Here is the symmetric cipher model, which show the major components that includes plain text, encryption algorithm, secret key that is generated using the key scheduling algorithm. This is the third entity. After that, a secure channel where the plain text is encrypted using the secret key, and now it is an unreadable form which is called the ciphertext. This ciphertext is transmitted in the secure channel, and the recipient, what he can do, he can receive this ciphertext converted using the same secret key and use the decryption algorithm, which is the reverse of the encryption algorithm, which gives the original text, or we say that plain text. Plain text is actually the original message. So decryption algorithm provide the same message that are encrypted using the encryption algorithm. Also, encryption and decryption can be thought of electronic locking. Symmetric key encryption, in which allies put the message in a box and lock the box using the shared secret key, whereas in the recipient, who is there? Bob. We say that two entity, Alice and Bob. Sender is the Alice and recipient is the Bob. Bob, what he can do? Bob unlocks the box with the same key and takes out the message. Okay, this is the concept of symmetric cipher model or symmetric encryption. Here is the model of conventional crypto system, which is looks similar as the symmetric cipher model as we discussed earlier, where also this key entity involves like sender, key source, encryption, decryption, receiver, and the secure channel where uh, the user or the sender can share the secret key. Here we will see that we have two key challenges. One is that we can share our same secret key with the secure channel, and second challenge is that when we encrypt the message using key, it convert to ciphertext. This ciphertext also is a possibility that can be attacked by cryptanalysis by the different ways. Maybe it can open by applying the different patterns of key. Maybe previously he can eavesdropping your message conversation or any other possible way. He can try to assess this cipher text. That's why for secure communication we need a powerful secure encryption algorithm which can provide the security of your data, of your information. So, in the recipient end, the receiver can decrypt the message by using the key that it received using the secure channel. You know, in any cryptographic algorithm, we have three major components that includes encryption algorithm, decryption algorithm, which is the inverse of the encryption algorithm, is the decryption algorithm. Third is the key scheduling algorithm, which provide this all different keys, different key patterns, different keys that uniquely use for any encryption or decryption of the message. So all the three algorithms should be more secure, more powerful if we say that any cryptographic, any of your information is safe. Otherwise, weak encryption or decryption algorithm or any cryptographic algorithm, the cryptanalysis may easy to attack. Later we will discuss the different attacks, how the cryptanalysis get your ciphertext, get the pattern of your keys, how he open the ciphertext, how he get the plain text. Okay, now we will move forward. Here is the requirements for the any cryptographic algorithm. Two requirements for secure use of symmetric encryption. First is the strong encryption algorithm. Second is the secret key known only to sender and receiver. In previous figure we already discussed if most secure and strong encryption algorithm which will provide more security to the data, and second case we will discuss is the secret key. We need secure channel during the sharing of this secret key. Mathematically, the encryption algorithm can be represented as y equal to e into k into x. So here is the case why we suppose that is the ciphertext is equal to encryption using E into encryption, K for key, X is the plain text. Encryption of original text or message or plain text using the key. And second equation we show X equal to D into K into Y. D base K into Y. D for decryption, K for key, Y is the ciphertext. Decryption of ciphertext using the key which return the original text, that is X. Next is assume encryption algorithm is known. Why? Because your information is your asset. You don't want to lose your information to the attacker. It may lose you millions of dollars maybe. So in this regard, before transmitting, before any transaction, you should know that which encryption algorithm use. So once you know your encryption algorithm is secure, then you are in safe condition. You feel more secure that your information will not read by advisory cryptanalysis. More importantly, like the military information, military secret information, they don't want to share with the another party, so that they need more and more secure encryption algorithm. Also, we need more secure channel to distribute the key. Next is the level of security, unconditional security and computational security. Firstly, in the unconditional security, no matter how much the computer power or time is available, the cipher cannot be broken since the ciphertext provides insufficient information to uniquely determine the corresponding plain text. Only one time pad. And second is the computational security. This is the possibility because we have two key points. First is the cost always matter and the time. Firstly is cost exceed the value of information. Second, this is also the possibility. Time exceed the useful life of information. Next is the cryptanalysis. Cryptanalysis is the study of ciphertext, ciphers, and crypto system with the aim of understanding how they work and finding and improving technique for defeating or weakening them. For example, cryptanalysis seek to decrypt ciphertext without the knowledge of plain text source. Encryption key or algorithm used to encrypt it. Cryptanalysis also target secure hashing, digital signature, and other cryptographic algorithm. While the objective of cryptanalysis is to find weaknesses in or otherwise defeat cryptographic algorithm, cryptanalysis research results are used by cryptographer to improve and strengthen or replace flawed algorithm. Both cryptanalysis, which focuses on deciphering encrypted data, and cryptography, which focuses on creating and improving encryption, cipher, and other algorithms, are aspects of cryptology, the mathematical study of code, cipher, and related algorithms. Researchers may discover methods of attack that completely break an encryption algorithm, which means that ciphertext encrypted with the algorithm can be decrypted trivially without access the encryption key. More often, cryptanalytic results uncover weaknesses in the design or implementation of the algorithm, which can reduce the number of keys that need to be tried on the targeted ciphertext. The two general approaches used by the cryptanalysis is cryptanalytic and brute force attack. Firstly, there are different types of cryptanalysis attack and technique which vary depending on how much information the analysts have about the ciphertext being analyzed. Such cryptanalytic methods include cipher text only attack. The attacker only has access to one or more encrypted messages but knows nothing about the plain text data. The encryption algorithm being used or any data about the cryptographic key being used. This is the type of challenge that intelligence agencies often faces when they have intercepted encrypted communication from an opponent. Second is the non-plain text, which also have a plain text for the ciphertext, in which the analyst may have accesses to some or all the plain text of the ciphertext. The analyst's goal in this case is to discover the key used to encrypt the message and decrypt the message. Once the key is discovered, an attacker can decrypt all messages that has been encrypted using the key. Also, the linear cryptanalysis is the type of non-plain text attack that uses linear approximation to describe how a block cipher. Non-plain text attack depend on the attacker being able to discover or guesses some or all of an encrypted message or even the format of original plain text. For example, if the attacker is aware that a particular message is addressed to or about particular person, that person names may be suitable non-plain text. In the next, in the chosen plain text, the analyst either known the encryption algorithm or has access to the device used to do the encryption. The analyst can encrypt the chosen plain text with the targeted algorithm to drive information about the key. Next is the chosen ciphertext. In chosen ciphertext, attack is an attack model where the cryptanalysis can gather information by obtaining the decryption of chosen ciphertext. From these pieces of information, the adversary can attempt to recover the hidden secret key used for encryption. Next is the brute force search. In general, this attack is possible if an adversary could generate one possible correct key from the large key space. Because adversary or cryptanalysis always try to search out every possible combination in order to get the required key. The attacker has no knowledge of encryption key, so the attacker generates and computes every possible combination of encryption key to recover the secret key that was used for the encryption. Its only aim is there to check every combination of your keys, like a journal log of the houses. We will see the key have different pattern of different logs. Similarly here, for the cryptographic algorithm, every key have unique pattern. So the major focus of the cryptographic algorithm is that large combination of the patterns of secret key will able to secure from cryptanalysis to attack. In this regard, different algorithm uses the different key size for their encryption and decryption process. Here is the some examples that previously and currently most of the algorithm uses the key size. First is 32-bit key size. How many the number of combination? In order to find out the number of combination, we use the formula 2 power n. So here 32 key size, which mean 2 power 32, which gives the number of alternative key 4.3 into 10 power 9, and also where they mention the time required at one decryption, how much time required to decrypt. Similarly, time required at 10 power 6 decryption, which is very less, 2.15 millisecond. Next key size is the 56, which is used in data encryption standard. 64-bit size, actually the 8 bits used for the parity bit, so remaining 56 bits used as the uh, for the encryption process. Okay, 2 power 56, the combination of alternative key is 7.6 7.2 into 10 power 16, and 1142 year required time to decrypt. and 10.01 hours time required at 10 power 6 decryption, whereas 128-bit key, the number of alternative keys is 3.14 10 power 36, and 5.4 into 10 power 18 year required to decrypt at 10 power 6. Similarly, 168 and later 26 character permutation. So if 26 characters, we will go for the factorial to 26 factorial. The alternative key is 4 into 10 power 26, which also provide the more time to decrypt at 10 power 6, which is 6.4 into 10 power 6 years. It's huge time, long time to decrypt the message. So we, during the development of any encryption algorithm, we need to focus on the algorithm is more simple, not more complex, and we try, our try is that the algorithm should be more efficient. So the both parameter we need to focus while developing any cryptographic algorithm. We cannot say that if we larger and larger the key size, which will slow down the processing, but it vary from application to applications. Okay, this is the end of second lecture. I will request you to subscribe our channel and don't forget to click on bell icon, which helps to give you the notification of our next lectures. I believe every one of you get more knowledge with this lecture. If you have still any queries regarding the lecture, please comment here. Thank you so much.